Hi everyone. This week we are going to be discussing assessment of understanding and inquiry. In addition to everything that's posted on Moodle, I also wanted to let you all know that I will be hosting office hours starting next week. Most of them will be during the day because I do have small children. However, if you need to meet with me after hours, I am happy to try to find time for both of us to meet via Zoom. And I do expect us to meet over Zoom if possible because it's a lot easier that way and I have documentation that we have met. So this week we're going to be discussing assessment and the NGSS. Then we're going to discuss creative assessments and then more traditional assessments that you may be familiar with. So before we start, I described backwards design to you all last week. And what I didn't realize was that some of you had never heard of the term backwards design before. So I will be posting some YouTube videos to this module in case you need more information about backwards design. But the whole point of backwards design is that before you even decide what activities you want to do in a lesson, you need to identify the specific objective that you want your students to meet. What is it that you want them to learn? So last week we discussed you need to identify the objectives you wanted your students to learn. And we need to know what we want to teach before you can assess it, hence why you teach your learning outcome first. Then we pick our assessment, then you pick your learning activities, and then you pick the content that is going to support your students understanding these concepts. So last week you picked your learning objectives, and this week we're going to start discussing what assessments you can use in your science lesson plans. Before we discuss assessments, like specific assessments, we should probably discuss formative versus summative assessment. Both types of assessment are expected to be in your lesson plans, and you should be familiar with this terminology. And if you're not, please let me know. But formative assessment is checking the execution of the plan. Are your students doing what they are intended to do? Are students learning science practice or core ideas? And you can do this through class discussion, while you're creating an anchor chart. You can do the thumbs up, thumbs down, where students self-assess themselves and tell you this was really hard, this was easy, I feel like a novice, I feel like a pro. You can do worksheets. I hate worksheets. I hate worksheets. I hate worksheets. And you can also do low stake quizzes. Summative assessment is a little bit different. That's you asking, what did the students learn? Did they learn what I intended to teach? So that is, are they meeting the lesson objectives? And usually the purpose of a summative assessment is for grading, placement, info for parents, and next year's teachers. And these types of assessments are normally exams, final projects, essays, and final presentations. However, a fishbowl class discussion could also be a summative assessment, or a quiz could also be a summative assessment. So these assessments can kind of go back and forth between the two. Before we discuss specific assessments, you need to think about assessment and the NGSS. The Louisiana Science Standards are derived from the NGSS, and if you teach in any other state, those standards were derived from the NGSS. So if we understand how to assess NGSS, we understand how to assess our own Louisiana standards. Assessment needs to be multi-dimensional. What that means is you're going to need to use multiple and varied assessments. In Louisiana standards, they give you an objective, then they give you a clarification statement, and then they discuss like cross-cutting things and other things that they want you to be able to do. It's the same in NGSS. So if you look over here, the core idea is the specific objective that we want you to meet. So in this case, for PS4.A, we want teachers to be able to teach that wave properties, waves which are regular patterns of motion, can be made in water by disturbing the surface. But you're going to want your students to be able to practice this by developing and using a model. And they're going to also need to recognize that there are patterns. So if you're doing a certain model where maybe students get a bowl of water and then they use different materials to create waves, they might start to see a pattern based on the materials that they're using to make the waves, how often the waves are being made, etc. So you need to assess not only do your students understand the core idea, but can they also practice the science and do they identify that cross-cutting concept? So first we're going to discuss creative ways to assess your students, and then we're going to discuss the more traditional ways. So creative ways to assess your students include prompt and rubric, performance assessment, portfolios, science conferences with children, children's self-assessment, concept maps, and then there's an additional one that you are going to do in your discussion board this week, and that's science probes. And we'll talk more about that when we get to it. So prompt and rubric. Prompt is a question or group of questions that include statements about a task to be done along with directions on how to do it. And the rubric is the scoring criteria that should be used when assessing a child's performance. So what does that really look like? Well, it's not actually you making them write the stuff down. This is you walking around the groups and asking your students specific questions and seeing if they're meeting the criteria. So here's an example from your book. So this is for sound, and the content to be assessed is that sounds are caused by vibrations. And students are given a drum, a pencil, and rice, and students will hit the drum with the pencil and explain orally that sound is produced by vibrations. So the prompt they're going to receive is, this little drum is made by stretching plastic wrap over a jar. I'd like you to tap the drum with the eraser and look at the plastic and tell me what you see and what you hear. Then sprinkle rice grains on the plastic and look at it as you tap it again. So those are the instructions that your students need to do, and you can put these instructions on the board as well as in front of them on their desks. And then the questions you want to ask your students are, what do you observe when you hit the drum with the eraser? And then what do you think causes sound? And here's your scoring rubric. So you can see, do your students really understand this? Can your students' description of what was observed include the plastic moves up and down and vibrations cause sound? Or maybe your student's description includes a response with one correct observation, or maybe they're giving you an incorrect response. So you could be walking around with a clipboard and just kind of marking 3s, 2s, and 1s next to students' names to get an idea of who's struggling with this concept and who is not. I like to do this to see, are my students using science vocabulary correctly? Are they able to discuss the observations they're making? Do they know what an observation means, particularly for your smaller students? So this is something that you might want to consider. And when I say smaller, I meant younger. Another type of assessment you can do is performance assessment. Inquiry involves descriptive models, explanatory models, an experimental model, as well as science practices like carrying out an investigation or planning an investigation. An inquiry is a process, therefore the assessment needs to happen over an extended amount of time. This is where I'd like my teachers to observe and document students' practices while they are engaged in doing science. So based on observation of students as they demonstrate a specific task or problem-solving skill. This could be, do your students know how to read instructions? Can they describe the observations they're making? Can they plan an experiment? Are they working well together, collaboratively? These are all things that you can assess. Here's an example of a performance assessment from your book. So here they're discussing light and plants. And so what they decided to do was in Mrs. Cortez's class, she gives the students 2 plants. And they have 1 week to find out what will happen to the plants if they are kept in a closet without light. And they need to think about the following questions to guide their investigation. So I need you to make a prediction that you can test. Describe how you'll test your prediction. Then carry out your test and make observations of your plants each day and record your observations in your science notebook using words and drawings. And at the end of the test, state your results. And so here you can see Mrs. Cortez's grading rubric. So she says, is the prediction testable? Does it imply treatments? Does it imply control? Does it identify observables like color, height? Did your student make daily entries? Did they write the label drawings? Are their observations accurate? Are the results consistent with their observations? And were the students able to explain their results? Now here's the deal. If you are using a rubric, you need to share with your students the rubric or how they're going to be graded so that they understand fully the expectations for them. Another way you can assess your students is through portfolios. I am a big fan of portfolios, and I'm going to explain to you why in a moment. These are organized collections of students' work representing the best that he or she can do. A portfolio as a whole illustrates your students' progress. I really like portfolios because if you start at the beginning of the year, students have this tangible notebook or digital notebook that shows how much progress they have made over an entire year. And that is really incredible for a student to be able to see. What might you include in a portfolio? It might be their drawings, charts, graphs that are products of hands-on discovery-focused activities. It could be reaction pieces, such as a written response to videos, field trips, visual labs, science journal pages, and it could be media products like student-produced work in audio, video, digital format. This could be creative stories, science vocabulary learned. It could be presentations that they've made, posters they've made. Something that I really like about portfolios too is you can use them during teacher-parent conferences. So if the parents want to know what their students have been up to, you can show them their portfolios, which is really neat for the parents to see as well. Another type of assessment you could try is a science conference with children. I'm a big fan of this, particularly if you're having a difficult time connecting with your students. It's the quickest and most reliable way to find out if children are learning. So what you need to do is you need to sit at their level. If that means sitting on the floor with them or at their desk, please talk in a cheerful tone. I think a lot of students think when they're getting individualized attention by a teacher, it means that they're struggling or they're in trouble. And inform the child while they get the special time with you. You can tell them, I am so excited that we are learning about the properties of light, and I want to hear everything you know about the properties of light today. Let them speak to you using terms they are used to using and have them practice science terminology. So be like, oh, what's the right term for that again? Do you remember? And use open-ended questions like, tell me about. What did you think about? How did you feel about? What if you were to? Is there another way to explain that? What could you change next time? And what questions should I ask the next student when I talk to them about what we're learning today? Another one I really like is science notebooks or journals. In elementary school, students aren't expected to keep a laboratory notebook. However, when they get to high school and college, it's a little bit different. So you're kind of priming them for how to keep a laboratory notebook in the future. I posted a YouTube video, which is in our module, on how science notebooks are used in elementary school classrooms, and I highly recommend that you check it out. So notebooks, they're devoted only to science, no other subjects. I recommend a composition book. Why? One, they're cheap. They're usually less than $1, particularly during back to school time. And two, the pages can't get ripped out. So you can't lose pages in the notebook. Why do I like it so much? You can use it to hit metacognition. You can include formal investigation information like procedures, data, and results. But you can also include informal information, like students' questions about the material, predictions they might make, reflections, and their feeling about science or how things are going, which is tremendous. And if they're leaving them in their desks, then you can just roll through the classroom during your break or after school and flip through the notebooks to see how your students are doing. I recommend that if you're going to keep science notebooks, that you make it fun. Have students decorate the cover of the notebook. Please use it consistently and encourage use of the notebook by providing guiding questions. So I'd be like, okay guys, so we just finished this experiment. I want you to paste in the worksheets I gave you, and then I want you guys to write what confused you the most and what surprised you the most about what you just saw or what you just did. And then schedule the time at the end of the unit for students to share with each other and you what they wrote or drew in their journal so they can share their own personal product. And again, you can use these notebooks during parent-teacher conferences as a work example. Science probes. This is what you all will be working on for your discussion board. So science probes are very similar to prompts and rubrics. It's designed to uncover if a student understands a specific concept. Probe is a question that seeks a two-part answer. The first part is normally a lower end thinking, such as identification and naming. And then the second part is usually higher end thinking by stating rules or relationships among elements of the lesson. And the younger the student, the more guiding you're going to need to provide. So, for example, the worksheet to your right would be something that you would use with kindergartners or first graders. So here we have 4 students that are discussing how scientists do their work. And this is what they said. And so you can see 4 different student responses. And then the lower end part of the question is, which students do you agree most with? So there they would just write the name of that student. But then the second part is explain why you agree with that student and include why you disagree with the other students. And this is where that higher end thinking comes in, where the student has to discuss why they are supporting one student's statement and why the others they do not support and what the reasoning is behind that. Another science probe example would be if you're discussing physical and chemical change. So physical change is like, an example would be like water freezing and then melting and evaporating. The composition of water is still 2 hydrogens to 1 oxygen, no matter if it's in vapor form, liquid form, or solid form. A chemical change is the actual compound is changing. So this is when we burn something or we mix 2 chemicals together, then you see a chemical change. So here you could say, this list below involves situations that cause materials to change. Put a P for physical change or C for chemical change next to each one, and then explain your thinking and write a rule to decide if something goes under P or C. So here we're asking our students to do something low level, in that they just have to identify if it's a physical or a chemical change. But then we take it up a notch with the second part of that question, where now we're asking them to write a rule to decide if something goes P or C. So for example, ice cream melts in the sun. Has the composition of that ice cream changed? No, it's just gone from solid to liquid. So that would be a physical change. However, wood is burned in fire. You're creating a chemical reaction with that fire, and the composition of wood has now changed. It's no longer solid wood, it's ash, which is probably multiple chemicals. And so that would be a chemical change. And then water evaporates from a pan. I gave you water as an example. That evaporated water is still 2 hydrogens and an oxygen. So again, that would be a physical change. So now I would ask the students, write in your own words a rule to decide if something goes under P or C. You can also have students self-assess themselves. Children naturally self-assess themselves, so capitalize on it, reminding your students what they did and asking, so what have you learned so far? What was easy to grasp? What was harder to understand? And you can do the thumbs up and thumbs down on what students liked and then tell you why. And here's a chart to the left that says, I'm a novice. I'm just starting to learn this. I'm an apprentice, a practitioner, or an expert. And so you could have your students either hold up popsicle sticks with those colors, or they could do the thumbs up, thumbs down, or something else, or, like the numbers of fingers. 5 is an expert, 1 is a novice, and show you how they're feeling about the materials that they're learning. Concept mapping. Why did Hollander make me do one? I think concept mapping is such a terrific way to assess your students, and it can be both formative or summative. I feel like students self-assessing themselves, that's not a good summative assessment. You can't use that as a grade, but a concept map, you could use it in either way. So concept map is a diagram that represents knowledge by identifying basic concepts and topics and showing you how they're related. I made you all do a concept map just so you could get an idea of what it's like. But you can use concept maps after an inquiry experience or activity. And I really like concept maps for English as a second language students because they can use symbols or drawings for it. And it also forces our students to use their vocabulary. You as a teacher can also use it as a planning device too. So here you see a very simplistic concept map. Here you see students are using pictures and arrows to identify parts of the plants and describing colors and other things. Here's some more on concept maps. If you want to teach the older students how to concept map with symbols, the node is the shape that contains the word or phrase. So this is when you'd want to use that scientific vocabulary. And the link is a line with an arrowhead at one or both ends that's used to connect the nodes and show relationships. And the key here is you need your students to write out that relationship. And then you can assess, do they truly have an understanding between these concepts? Do they know how to use scientific vocabulary appropriately? Now, there are traditional assessment strategies that we're all familiar with, and there are pros and cons to traditional assessments, particularly when assessing inquiry. Traditional assessments include end of chapter assignment, quizzes, end of unit tests, research reports, activity write-ups, and standardized tests. End of chapter assignments. Basically, those are, did your students remember what they read? What does it accomplish? Well, it makes your students read to at least find the answers, and it helps you understand what level of reading comprehension your students have. You can use it as homework, so parents see students are learning about science. And if not done, you can meet with the students and parents to discuss why they're not doing their work. But what does it not accomplish? It doesn't tell you what your students know. It doesn't tell you the students understand the material or like it. So if you're going to use an end of chapter assignment, use it effectively. Tell your students why you're assigning it. The questions at the end of the chapter help you apply what we just went over. We were discussing what is living and what is not living, and what are the different components of life and not life. And then have your students understand, I want you guys to now put everything we talked about together with what's in your chapter to answer the following questions. I also recommend that you give students a few minutes in class to start it and ask questions. Students are more likely to complete something that they started in class. But here's my crazy idea, particularly for your students that are in 4th grade and up. Why don't you teach your students to take notes or fill out a study guide? So instead of you having them finish the end of chapter questions, why don't you teach your students how to outline a chapter? And you can scaffold this and teach them various parts of how to outline. Or you could also do like a fill in the blank study guide with leading questions. So instead of them having to do these end of chapter questions, you're helping them understand how to create study guides, so as they go up in grades, they know how to create those in the future. Quizzes. Quizzes are great because they take a little time, it's a quick assessment, and if students remember or understand information or concepts. So what do they accomplish? Basically, they can accomplish, can your students think fast and write their answers out correctly or select the right answer? They're easy to grade and they provide a snapshot of student recall. What they don't accomplish: there's not much in-depth understanding, and deficit in knowledge or ability to get the correct answer down on paper in time. So do you know that your students don't know the answer, or do you know that your students don't know the answer in time? I also don't really understand, I see a lot of this in lesson plans, that you expect your students to do something in 5 minutes or less with an 80% proficiency. That's absurd. Everyone works at a different pace, and I don't think that that's a very good assessment. If you're going to use quizzes, use them effectively. Don't let them take away from the science experience. Please use quizzes in moderation and keep them short and very focused on the important ideas or concepts of the lessons. Your students should not sit through a lesson with you and do an activity and have no idea what they're going to get quizzed on. It should be very, very specific to what they learn, and you should be the one making it very clear what your students are expected to know. End of unit tests. Oh man. Short answer multiple choice questions. Essays should be how science activities were conducted and what did you learn from them. So what does an end of unit test accomplish? It accomplishes you identifying who's a good test taker. It compares students to one-on-one in progress. You can create tests with less recall and more reasoning, And you can have students analyze data or look at a graph on a test, which is good, but they don't accomplish. They don't motivate students to think science is cool, and they don't tell you how well students can express themselves. If you're going to use an end of unit test, which I think we all have to, because every 9 weeks your parish is going to require you to have exams and assessments for your students for grades, make sure every test item can be directly linked to a learning objective from the lesson in the unit. Please consider the order of questions and difficulty. If a student reads the first question and it's really, really difficult, they might shut down and give up right away. So I always like to start my exams with easier recall questions and then build them up to the point where we're at higher level blooms like synthesis and explanation. And please use various levels of bloom. Don't make your science exams just straight vocabulary. They should be able to look at examples of phenomena, they should be able to look at data, and they should be able to make reasonable assessments for both. Another assessment you can use are research reports. What are they? They're basically lab reports. I like these in older grades. This should not be an expectation for first or second graders. It helps students explain and connect the hands-on activities they did in class to real-world situations or problem solving. But you need to use them effectively. Relate what your students are learning to their own world. If you're going to give them a problem to solve based on what they've learned so far in science, it needs to be a problem that they can relate to. Make your expectations clear and your grading rubric available to your students. Please consider your English as second language and your dyslexic students if you're going to assign a research report, and scaffold. So here you see on the right an elementary research guide. So here you see this teacher is helping them identify the question, how to create a topic sentence, and then what they learned in sentences to create the paragraphs for their research report. And then below that, you can see the students are learning to identify their references and record the references. You really have to do this step by step and break down that research report, particularly if it's the first time they've ever done it. Another one you can do is an activity write up. So the students do an activity and then they write it up. And here's an example. So the title, the date, the aim, which is the learning objective, what equipment did they use, the method, what did they do, and what are the results. But what is your activity write up missing? Your activity write up is missing how to explain what they saw. It's missing, them explaining why they saw the observations they did, how would they change things in the future, if they had to do it again, how is this relatable to other things they've learned in class or things that have been presented to them in the real world. So if you're going to do an activity write-up, consider adding more to it than just them writing down what they did. You need to take it to the next level for them so you can understand, do they really understand what they're observing and how it applies to the topic I'm teaching them. And then finally, standardized tests. I'm not going to talk about what's in your book. We're going to talk about real life here. Standardized tests are really important for you and your students. They determine what type of funding your schools receive, and they are part of your assessment as a teacher, unfortunately. So what I ask of you is once you get into your grade, you need to take a look at the LEAP questions. So if you go to Louisiana Believes, you will see that there's a whole section for science, and there's PDFs with test answer keys for grades 3, 4, 5, 6, and then if you end up in middle school, there's LEAP testing for 7th and 8th. Please prepare your students for the testing environment. Use the types of questions that you see on these old LEAP exams in your own exam. So if you're going to be giving exams, write your exam questions similar to what they'll see in LEAP so it's not shocking or confusing. If the LEAP exam expects your students to be able to read a graph, then you need to include graphs on your own assessments. If the LEAP exam expects students to read a paragraph and then pull out important information from it, you need to teach your students how to do that. When you get close to standardized testing, manage your own stress. Your students are going to feed off of you. It's very stressful. I feel like teachers can make it feel like everyone is on the verge of tears during LEAP testing. And it doesn't need to be that way. This is a fact of life. It's going to happen over and over again. You need to manage your students' expectations. You need to practice the types of things that will happen during the LEAP test in your own classroom so that they don't freak out. And more importantly, you need to manage your classroom anxiety level. You can teach your students before tests how to take deep breaths in, how to relax. You can do an activity to get their wiggles out if you expect them to sit there for 20 to 40 minutes to take an exam. There are a lot of things that you can do to help your students manage their anxiety. And finally, any assessment that you provide your students needs to be intentional. Do not give quizzes to give quizzes. Do not make them do worksheets to do worksheets. Busy work is boring and your students will see right through it. Make sure everything that you are assessing makes sense to that student learning objective you have chosen in your lesson plan. You need to assess often. Science is a process. You have to assess various points in that process. If you're expecting students to create a model and then see what happens with it, then that student needs to be assessed on their ability to both create and execute that model. Thank you guys so much. Have a wonderful week. And if you have any questions, please email me or come to my office hours. I'll talk to you real soon. Thanks.